Welcome to the lecture on simple discount, focal date and equation of value. So, in this lecture we are going to extend our interaction which we did in the last lecture regarding the simple interest. So, what we studied in the last lecture, it was about the interest amount which is to be paid, and what we saw that normally you have the value which is at present with you, that is your principal amount, or that is also known as the current value CV. Then so current value which is used for calculating the interest, and for that you need to have the rate of interest which must be known to you, and also the period of time. So, once you know the current value and the rate of interest and the period of time, so you can calculate this total interest which is basically to be accrued on, and then accordingly you can also calculate the future value. So, if you you can obtain this current value from future value, further interest rate and time. So, once you have an expression, that expression can further be used in many ways. Many a times you may require to find the interest rate, or you may require to find the period of time, or you may require to find the current value. So, based on that basically you can have these values, like suppose you have to find the interest amount, that is I. So, I, that is total interest, and this will be basically current value. So, this is CV, we represent it through the term CV, and then we have R, that is your rate of interest, and then you have this N, that is your period of time. So, that is how you have if you have any principal amount, that is your current value, it will grow over the time because you will have the future value, that will be the current value plus the interest amount which is accrued. So, R is rate of interest and N is basically the period. So, certainly rate of interest will be specified, and that is normally for 1 year. So, if the interest is to be used for smaller period, then accordingly you have to adjust that N. So, suppose for 6 months, then N will be 1 by 2, and if provided your interest is defined, the rate of interest is defined as 10% per annum. So, by default we consider it as per annum. So, then from this expression can be further used for calculating. Suppose you may be required to find the rate of interest. So, from this expression itself, if you have, and if you know the total interest, so in that case I upon CV, that is current value, into N. So, this way you can find the rate of interest. Similarly, if you have to find the current value and you know the interest and interest rate and also the time for which the interest is calculated, in that case you can find I upon R into N. So, these are basically the different expressions which can be used for finding the one of the parameter if when you know other two parameters. Similarly, what we have when we may have to find N. So, N is you can find as I upon CV into R. So, N basically is known as term of maturity. So, that is that is the business term which is used. So, N is the term of maturity, and by that you can have it these values. Now, many a times what happens that your current value and future values both are known. So, when current value and future value both are known. Now, before that we must know that once you know the period of maturity, then you know that the future value will be basically current value plus interest. So, you know that in the current value total interest will be added, that will give you the future value, and since I is CV into R into N, so CV will be common and you will have 1 plus Rn. So, this expression will be mostly used when you have to find the future value, then you can have, and you know the CV, then in that case you can find use this expression to find the future value. Now, many a times you know the future value and the current value, and you may have to find the either R or N, suppose in those cases. So, once you know that, so as you know that FV is CV into 1 plus Rn. So, from this expression FV equal to CV into 1 plus Rn. So, what you get is 1 plus Rn will be basically CV by FV by CV. So, this will be FV upon CV. So, Rn will be so this will be FV upon CV minus 1, and so this will be Rn. So, from this you can find either R or N. So, if you want to find R, suppose it will be FV upon CV minus 1 upon N, or if you have to find the term of maturity, in that case N will be FV upon CV minus 1 divided by R. So, this way when your these both the FV and CV is known and one of the R or N is to be calculated, another is known, in those cases you can use these formulas to find the other one, like you have to know R provided N is given, or you have to find N provided R is given. So, you can use these formulas. Now, you may deal with these different type of questions once you go to the that lecture where we will solve the problems based on these concepts. Now, there is another concept, that is your simple discount. Now, what we see is that basically if we are reversing this process of obtaining this future value, and we obtain this current value from the future value. So, that is through this concept of having the simple discount. So, basically we know that FV is CV into 1 plus Rn. So, when so in that case your CV will be FV upon 1 plus Rn. So, the current value that will be your and the difference basically will be known as the simple discount. So, what happens that we are getting this current value using this simple discount formula, and if the it's nothing but basically we are finding the future values equivalent at present time. So, that way we use it, and you can say for we can understand it by example. And now, what happens that normally we are dealing these cases with two types of cases. Suppose it may be a non-interest debt, or so that is what it is. Now, we can obtain this current value from the future value, interest rate and time, and concept of simple discount is used to bring back the future value back from its maturity date to the current time. So, that is how this simple discount, and the difference basically is termed as the simple discount, and it may be for two types of cases or debts. One is non-interest debt and another is interest debt. So, let us take the example of some case like a non-interest bearing type of future amount. So, suppose you may have one example where suppose you have a debt of rupees 5,500, let us say, and it is due in 8 months. okay, and interest rate is basically 6.5%. So unless otherwise specified, it will be 6.5% per annum. Now, in this case, if you look at, so you have to find the simple discount, and the in those cases what you have to see is that what will be its simple discount. Now, if you try to find this simple discount, what we see is that the current value, if you find from here, what will be there. So, what you see is that current value is future value divided by 1 plus R n. So, that is how you have to find. So, basically debt of rupees 55,000 is there. So, that becomes the future value, and so you will get F b upon 1 plus R n, and so basically you have to find determine the simple discount. Now, for such case you have to find, and F v is known, time is known, interest rate is known. So, if you look at that, it will be 5500 divided by 1 plus R is basically 6.5%. So, it will be 0.065, and it is 8 months. So, 8 by 12 years. So, you will have 8 by 12. So, this comes out, if you do the calculation, it will be coming out to be 5271.56. So, what you see is that you can have the discount of the amount, that will be 5500 minus 5271. So, this discount which you are getting, that basically is known as the simple discount. Now, this is for a case when you have this is a non interest bearing case. Now, if you talk about one interest bearing future amount when you have, so for interest bearing future amount, now what happens that there may be a situation, suppose now in that case someone has borrowed. So, a person borrowed rupees 3,500, suppose. Now, he has borrowed at 12% for 10 months. Now, what happens that after 3 months, now he has to go at elsewhere, and he wants to return. So after 3 months, he wants to settle by, so basically by having offer from lender. Now, that lender offers him a discount of basically discounting the loan by discounting loan at 14%. Now, in this case basically what will be, how much he has to pay. So, how much he has to pay. Now, this is suppose the case where he had after 3 months only he had taken the loan, how much he or she has to pay. Now, what is the problem is that he had taken the loan for 10 months, and after 3 months only he wants to return it. So, basically the lender has given him further, he has discounted the loan at 14%. So, that way what he has to pay. So, for such case what you have to do is that Now, if he has to suppose he has gone for 10 months. So, in that case what will be its future value. So, what will be happening, future value will be C v into 1 plus R n. So, C v is 3500 and 1 plus R n. So, R is it is given as 12%. So, it will be 0.12 and n will be 10 months. So, 10 by 12. So, that becomes like 3850. Now, the thing is that for 6-7 months that loan is discounted at the rate of 14%. So, this amount is discounted for 7 months. So, for 7 months you have to find its current value at the end of 3 month or 7 month period. So, what we will find is, for that basically you have to have the C v as f v by 1 plus R n. So, this will be 3850 divided by 1 plus 0.14 and it is at the rate of 14%. So, 0.14 into 7 months. So, 7 by 12. So, if you calculate this amount, it will be 3559. So, this person has to pay only 3559 rupees in that case. If you look at other way, he might have to pay something different, but since he is discounted and how we consider that one. So, that is clear from such cases. So, this way we can calculate these amounts for the different cases. Now, we will be talking about how to calculate the term in days. So, we know that if you are given a period specified, like suppose for 3 months or 10 months. So, you can have that n as 3 by 12 or 10 by 12 or so, but many a times for the business calculations there you have to calculate that term in days. So, in my 1 month for 15th of September it is given, and then you have to calculate maybe in the next year 10th of August or so. So, accordingly you have to calculate those dates, and normally you take the difference. And the thing is that normally what we do is we start and so by taking the difference and then divide it by the number of days in the year. So, once you calculate the number of days, in that case you have to divide it by 365. So, the convention also is that you are excluding that day, first day. So, if you are going from 15th you suppose 10th of September to 15th of September. So, in that case 10th is excluded. So, 11, 12, 13, 14 and 15, 5 days. So, basically you take the difference of 15 and 10, that is 5. So, if you look at in that way there are 6 days, but the first day is excluded. So, that way it becomes the number of days, and then you have to divide it by the number of days in the year. So, that will give you the calculating the term in days. Okay. So, in days you can do it. Now, once you find the days, then you can divide it by that 365 or so. So, you can divide it by 365 or 366 also in the leap years. So, that way you have to take. In normal case we do it by dividing by 360. So, that is how we do it, and in approximate terms. So, in approximate term we divide by 360. So, you assume that there are 12 months and every month is of 30 days. So, you take it that and then you calculate that the amount of interest based on that approximate term days. So, that is how you do it. Now, what happens that you have ordinary interest as well as you have exact interest. Also, ordinary interest will be based on 360 days. And exact interest will be calculated based on 365 days. So, that is how you will have you will be getting some difference. Suppose any amount is there. So, if you have 90 days, so for ordinary interest 90 by 360, so 1 by 4 will be n. However, for exact interest will be 90 by 365, it is not a leap year case. So, in those cases you will have 365. So, basically you can compare these ordinary and exact interest rates in such cases. So, what you do find is that with ordinary interest rate you get as CV into R into N. So, if you know the number of days, so N will be 360. So, N is number of days. And if you look at the exact interest, it will be CV into R into N upon 365. So, basically there will be difference in both the cases, and what you see is that from this you can have the relation between these two terms. So, if you find I naught by I e, that ordinary interest by the exact interest, so it will be 365 by 360. So, that is how you can further divide it by 75. So, it will be 73 by 72. So, it will be 1 plus 1 by 72. So, what we see is you get I O will be I e into 1 plus 1 by 72. So, that is how you get these values, or you will also get I O as 1.014 I e. Now, so you can even get the expression for I e, suppose. So, I e will be I 0 by 1 point, or I e will be I 0 by 1.014. So, this is how you can have the expression for ordinary interest as well as the exact interest values. Now, what we intend to see the another term that is known as the focal date. Now, what happens that money's value is fluctuating with time. So, we need to know something about the focal date. So, we have studied about the calculating the term in days, exact time and approximate time. Now, the focal date is the date at which various funds are to be chosen to be evaluated. So, basically what we see that many times many payments are due at different points of time, and we know that the money has time value. So, with that time it will have different values. Now, when you have to compare or when you have to find a value at a particular time, so that is basically more convenient. Suppose somebody has for someone some amount is due after 2 months, some another amount is due after even 4 months, and some third amount is due after 6 months. Now, how much he has due on in the last day? So, the amount may be A1, A2 and A3. So, it will not be A1 plus A2 plus A3, because they are being transacted at 3 different times. So, basically you have to find the value of all these at one particular time, and that time or that date basically is known as focal date. So, how to have what is the significance of this focal date, and that can be understood by dealing with certain examples. Suppose a person he has received a loan, and a person received a loan, and he has to pay in 3 installments. He has to pay in 3 installments. Suppose those installments are like rupees 500 in a year, then rupees 2000 no 1200 in 20 months, and rupees 1500 in 2 years. So, what would be the amount of loan received if the annual interest simple interest rate is 9.5%. So, interest rate is 9.5%. Now, the thing is that if you want to know that how much basically was the loan because of which he has to pay rupees 500 in the year end, rupees 1200 after 22 months in 20 months, and rupees 1500 in 2 years. So, basically what you need to do is you have to find its equivalent values. You have to map all these values to a particular day, and if you want to know the loan amount, how much he has taken, basically you want to know now. So, basically your focal date is today. So, focal date is today. Basically, if you don't want what amount of loan he had received, if you want to know amount of loan he received. So, that is how. So, FEC means on that particular time you have to find the equivalent value of all those payments which has been made. Now, if you look at that, in that case the current value basically will be current value component of rupees 500. So, this will be first future value. So, FV1 divided by 1 plus R N1. N1 is, so FV1 is 500 and N1 will be 1 year. Similarly, FV2 will be 1200 and 1 plus R N2 will be the second installment at which it was paid, and that is given as 20 months. So, it will be 20 by 12 years. And similarly, FV3 divided by 1 plus R N3. So, FV3 will be 1500 and N3 will be basically it is 2 years. So, 2 N will be 2, N3 will be 2. So, if you find this value, so 1 plus R will be 0.095, and then if you calculate all these values, what you will get is you will get something values close to 2753. So, what we find that by finding this focal date, you can you have to decide what should be the focal date. So, based on that you will have to convert, either it may be the future value or it may be the current value or so. So, you have to compute the respective amounts, and then you have to calculate it and tell, and then you can sum it up because it is happening at a particular time. So, you can very well sum it up and find what will be the value, ultimately what is the amount of loan he had to pay. Now, also we must know something like, so what we saw is that now focal date can be changed also. You can have a focal date in the future also, and in that case all the transactions which has been done its future component. So, in that case you will be knowing current value. So, you will be multiplying with 1 plus R n, and if there are many transactions, then all transactions component will be calculated, and then they will be added. Like that it will be done. So, basically when you are obtaining one payment at the focal day for two obligations, basically if you have two obligations, and if you are obtaining that one payment at the focal day, then and basically they are also due for different dates, then this method by which you are obtaining, that is known as the equation of value. So, basically what you do is, suppose at this point you have to find. So, if you are talking about focal date at a particular time, it is the current value, and then you have a future value. So, if you are finding the current value and the future value, so in this case if you are doing so if anyway in this case we are always calculating current values, but we may deal with a situation where you have the transaction at a particular point and other transactions its component is to be calculated. So, in that case what you do is you calculate the FV plus CV and you add them, and that way you get x equal to FV plus CV, which is known as the x discount equation of value. So, what we are doing basically in the equation of value is we equate the unknown single payment when you have two obligations. So, we are basically equating the unknown single payment that is x to sum of growing first payment, that is so that will be FV, and then you will have the and the discounted second payment, that is your CV. So, in that case we are having the expression like x equal to FV plus CV, and this is known as the equation of value, and this is what is used. So, this is the mathematical equation. So, this is the mathematical equation which will be expressing the equivalence of these amounts or original obligations which is due on specific dates, and the interest rate is given, and this equation is known as the equation of value, which will be used in our when we solve. We can also see when we solve the problems based on these expressions. Thank you very much.